Welcome to LIB Academy, and in our previous videos we dealt with how to write the net equation for um, decay series, specifically the three types of decay series that actinide elements undergoes. And we learned how to write the net product of the equation by knowing the number of alpha particles and beta particles involved. But what if, let's say, I have my nuclide this and I keep it somewhere, and for about a period, then I now come to check my element to see that this is the final product that I got. This is the element that I keep, and I kept and later on realized that my element this is no more this again, but it's now this one. So it means that this element has undergone decay process by releasing particles. But how do I know the number of particles, either alpha particles, the number of alpha particles or beta particles involved in the reaction? In the in the reaction to give me this product. So to do that, there's a way of detecting that. That is why I start this question about what if. So let's see how to do that. So given that we have protactinium-234, which decay to give out 214. So determine the number of alpha decay, beta decay, and total number of decay particles. And then 4, the type of 4n decay series. And 5 to write the net equation for the process. So let's continue. Now to calculate for the alpha particle number of alpha decay, what we do is we use this formula. Alpha decay is going to give us change in mass over 4. So the nuclei that we have, the starting and the product, we just have to look out for the difference in their masses and then divide it by 4. The value that we get is going to give us, that will be the total number of alpha particles involved in the decay process. So this is going to give us, we have 234, so 234 minus 214, so 214 all out of 4. So this is going to give us 5. So we have 5 alpha decay or alpha particles in the process. So that is for question 1. Let's solve question 2, which is looking out for beta decay. And for beta decay, we are going to use a formula like this. We have our final protons involved minus our initial proton minus sum of alpha particles involved in protons in alpha particles involved in the process. So looking at this, what is our final proton and what is our initial proton number? So this is our final proton number, which is 83, and this is our initial proton number, which is 91, right? So now let's go ahead by filling in. So we have final proton number, which is 83. So 83 minus into bracket initial proton, which is 91, minus sum of protons in alpha particles. We calculated our alpha particles to be 5. So we got 5 alpha particles. And each alpha particle has 2 protons. That means to get the total number of protons in the alpha particles, we have to multiply 5 by 2. So 5 by 2. So at the end of the day, we are going to get 83 minus into bracket 91 by 10, and this is going to give us a total of 2 beta particles. So that's it for question number 2. And question number 3 says that we should calculate the total number of decay particles, and which is obvious. From we got 5 alpha particles, and here we got 2 beta particles. So the total number of the decay particles is just going to be 5 plus 2, which is 7 particles, 7 decay particles. The question does, yes, total number of decay particles, that's it. And number 4 say the types of 4n decay series. So what type of 4n decay series is this? The 4n decay series type that we have are 4n, 4n plus 1, 4n plus 2, 4n plus 3. So how do we know whether this is a 4n plus 1, plus 2, or plus 3? Well, we just look at the masses either this mass or this mass, the mass of this nuclide or the mass of this nuclide, you divide it by 4. So if we take any of these masses and divide it by 4, either this or that, by 4, and you got a result which is exactly a whole number, then it is going to be a 4n decay series. But if you get a value 0.25, is going to be 4n plus 1 series decay series. And if you got something 0.5, 4n plus 2, so something 0.75 is 4n plus 3 decay series. So now let's go ahead and see. So we take 214. Let's take 214 for instance. You can decide to take this 214 over 4. This is going to give us 53.5. So and 53.5 means a 4n plus 2 decay series. So this is a 4n plus 2 decay series. So that's it for question 4. And question 5, that we should write the net equation for this process. And to write the net equation, we know the total number of alpha particles that were emitted and beta particles that were emitted too. So we got how many alpha particles did we got? How many alpha particles did we get? We got 5 alpha particles, right? 5 alpha particles. And we also got 2 beta particles. So in this case, we can write the overall reaction. We know that protactinium 23491 gives us 21483 bismuth plus 5 alpha particles. So 5 alpha particles. You know the mass of alpha particles for 2 plus 2 beta particles too. So 2 beta particles. So this is a net equation for this process. So hope this video is helpful. So thank you for watching, and don't forget to like this video to support me by liking this video and subscribe to my channel. So